Hello students. Today we are going to discuss about the unbalanced data. What is exactly the overfit, underfit and the best fit model. So first of all, I want to tell you that what exactly the unbalanced data or what exactly the balanced data is and how unbalanced data will affect the performance of the model. So see, whenever we are talking about the data set, just take a simple example. When we are talking about the data set, suppose I'm having 1,000 images, okay, and I'm having 1,000 images in which we are having cat image and the dog image. So if the 500 images belongs to the cat category and the other 500 images belongs to the dog category, then we'll call it as balanced data. And whenever you are having balanced data, it means what exactly it will help us. See, you are giving the 500 images of cat to learn to the model, and the same time you are giving the 500 images of the dog to learn the features of the dog. So the learning is equal for cat classification as well as the dog classification. So there is a possibility that model is learning the features of both the animals. So the performance of the model will be better if both the classes are having same number of images or same number of data. So it will affect your performance of the model. In the same way, you take another example. Suppose you are having again 1,000 images. Out of 1,000, 800 belongs to cat and 200 belongs to dog. So what will happen in that case? Your model is learning more about the cat features and learning less about the dog features. So whenever you are giving the cat images, there is a possibility that model is performing well. The accuracy is high. But when you are giving the dog images, maybe the learning was less. So there is a possibility it will affect the accuracy of the model. So that's the reason the balancing of the data will always play an important role. So if you have unbalanced data, it may lead to the bias towards any of the class and maybe the possibility the performance of the model will be less. In such situation, your accuracy and other metrics like precision, recall, and F1 score may compromise. So that's why the balancing of the data plays a very important role here. Now the question is, I have most of the time unbalanced data only. So the question here is how I can balance my data. To balance the data, we are having two techniques here. One is called oversampling and the other one is called random undersampling. So what is oversampling? Oversampling means what? You can understand with the name itself. Take an example here. You have a class B which is having a good amount of data available, and for class A you are having less amount of data. So what you have to do here, you are trying to perform oversampling of the data. So what you are doing, you are creating a replica of your same data multiple times, so it will become equal to the class B. Suppose class A was having 800 images and class B was having 800 images and class A is having only 200 images. So you are replicating the class A image four times, then it will become equal. So this is called oversampling. So this is one way of coming out from the problem of unbalanced data. The other way is undersampling. So just it is opposite of oversampling. So what you are doing here, you have again class B data which is lesser than the class A data. So what you are doing, you are just simply reducing the class A data. So both the classes will have equal amount of data. So this is called undersampling. So you can use oversampling or you can use undersampling. But if you're going with the undersampling, what is happening here? We are reducing the data. So definitely the learning will be less comparatively. So maybe this also will affect the performance of the model here. But still we have these two methods, which is oversampling and undersampling. So I hope it is clear what exactly the oversampling and the undersampling and how it will solve the problem of unbalanced data. The next topic here is we are going to discuss about overfit, underfit, and the best fit. Uh, will always likes to buy clothes. Okay, and whenever you'll buy a cloth, you'll see that that cloth is overfitted to you, or it is underfit, or it is a best fit. You can see this example here. Okay, so you can see a person is wearing three different type of cloth, and his face is sometimes sad and sometimes happy because of the fit of the cloth. The same sometimes we will feel whenever we go for shopping. So same way we are trying to learn about the overfit, underfit, and the best fit in terms of machine learning. Fine. So what exactly the overfit or underfit? See here, what does overfit means? See, when we are talking about a model, when your model is performing well on the given data set, you have a phases of training, testing, and validation. First, you are training your model. You have trained your model on some data set, and now you are performing testing of that model. Okay, I have given you 5 questions. You learn those 5 questions, and now I am giving the same 5 questions for the exam. Definitely, you will perform well because you learned properly. Okay, so but model will not behave in that way. You will not get the same question every time in the exam. You learn some 5 questions. Now the questions are a little tricky, or they change the way of asking the question. Now you are not performing well on those questions. It means what? You are not performing well during the exam. You are not performing well on unseen data, but you are performing well on the seen data. So this kind of problem is called what? Overfitting. It means model is performed well during the training, but while testing, model is not performing well. So this is called overfitting. So there could be multiple reason of overfitting here. There is a possibility the noise is present in the image. There are outliers present in the data. There could be missing values, and there could be a imbalanced data, or we can say unbalanced data. So because of these reasons, it will affect the accuracy of the model, and such problems are called overfitting of the machine learning model. Now, before understanding the more about the overfitting, I'll just try to introduce some of the terminology which we are going to use in further topics. So we'll discuss noise, bias, variance, and generalization. So what is noise? What you'll understand with noise here? Noise is nothing but which is not which is not relevant to us. Okay, I'm teaching you people, and someone is disturbing me every time. So this is not relevant what we are doing now. The same way you have some data, and some data is missing, or some data is meaningless, which is present in the data set. So that is called noise. So whenever you have noise in the data, it will affect the performance of the model. So better you should remove the noise before giving to the model. So this is about noise. What exactly the next is bias. Bias is what? When we are talking about bias, bias is a prediction error. Okay, and whenever your model is performing well during the training but not performing well during the testing, then it is called high bias. It means there is a difference between predicted value and the actual value. Your model is saying cat as a dog, that is what? That is a difference. So this is called high bias. When your model is saying cat as a cat during training as well as testing also, this is called low bias. So there is a less difference between training and the during the testing and the prediction training, then it is called low bias. Clear? When we are talking about variance, variance is what? When your model is performing well during the training but does not perform well during the testing, then it is called high variance. Clear? High variance means your model is saying cat as a cat during the training, but your model now saying cat as a dog during the testing. So it is what? There is a lot of difference during the training phase and the testing phase. So high variance lead to the overfitting of the model. Okay. Generalization means what? Your model is performing well during the training as well as the testing also. It means during training, your model is saying cat as a cat, as well as during testing, also model is saying cat as a cat. So this is called what? Generalization, which we will call it as best fit of the model. Take a another glance how the best fit, underfit, and overfit works here. So when you are saying overfit means what? When you are having low training error, means in the during the training your model is performing well, but during the testing your model is not performing well. This is called overfit. Overfit means you have low bias and high variance. You are performing well during the training but not performing well during the testing. So this is called low bias and high variance. Optimum means what? When you are performing good in training as well as good in testing. You have low bias and low variance, then it is called optimum, or we can say best fit. Underfit means what? When you are not performing well during the training itself. Okay, so that is called what? Underfit. Means you have high bias, and there is a feasibility that definitely you can have high variance also. So this is called underfit. So I hope it is clear what is overfit, underfit, and best fit. Overfit means low bias, low variance. Underfit means high bias, high variance, and best fit means you have low bias and low variance. Clear? So whenever we are talking about overfit and underfit, there are two main problems in the machine learning model which cause the performance of the model. So whenever we are talking about the overfit, it means model is not performing well during the training phase, during the testing phase. It performed well during the training, but when we are going towards the testing phase, it's not performing well. It is not giving the better result when it is seeing some new data or unseen data. So that is called overfitting. And whenever I'm saying overfitting, I told you earlier, overfitting is what? You have low bias, but you have high variance. Take another example of overfitting. Just we are saying that suppose there are three students present in the class, X, Y, and Z, and all are preparing for the exam. There is a X who studied all three sections of the book and left all other sections. Fine. Why is good in studies, he memorized everything which is there in the book. And the third student is Z, who studied everything and practiced all the questions also. Now, what is the scenario in the exam? So, if I'm saying X, X can do here? He can solve only on the question which comes from the first three sections. He can perform well for seen data, but he cannot perform well for unseen data. That is the problem with the X. If questions are coming from first three units, he can perform well. But if question is coming from other two units, he cannot give the answer. So he can perform well on unseen data. So X is what? Not performing well. If I'm talking about Y, so what Y is doing here? Y will be only able to solve the question if they appear exactly same as given in the book. Yes, but Z can solve every problem because he did not memorize, he learned, he practiced the other questions also. So Z can perform well than X and Y here. So in the same way, same thing happened with the machine learning algorithm also. If the algorithm learns from a small part of data, so it is unable to capture all the features which can be present in the model. So there is a possibility of underfitting. It means model is not performing well during the training itself. And the same way, suppose the model learns from the training set data like Y, so it will perform well on the seen data, but there is a possibility that model is not performing well on the unseen data. So this is called overfitting. Fine. And if your model is performing well during the training data set as well as for unseen data also, similar like your Z, he's a great student as good teachers like. Hmm? So that type of model is called good fit. Clear? So what is best fit, underfit, and overfit? Thank you.